Hello everyone, today we're going to learn a few things about the landing of Chandrayaan-3 and Chandrayaan-3 itself. This is Somay Kim Valte and I'm a student of BTech EC. So let us get straight to the introduction. As we all know, India recently launched Chandrayaan-3 and landed it on the moon's south polar region. So ISRO successfully landed Chandrayaan-3's lander module Vikram along with the rover Pragyan on the moon's south polar region at the Shiva Shakti point. So ISRO as we know it is Indian Space Research Organization. The landing was achieved on August 23, 2023. Launched on July 14, 2023 from the Satish Dhawan Space Center in Sriharikota, the Chandrayaan-3 mission aims to demonstrate India's ability to soft land and operate a robotic rover on the lunar surface. It is said that the spacecraft entered the lunar orbit on 5 August. So basically, it took around 18 days to 18 Earth days to land on the moon. The mission was a significant achievement for India, making it the fourth to successfully land on the moon after the US, China, and Russia. So question may arise on why this landing by India was such a significant achievement. So the reason is that it successfully landed on the unexplored south pole of the moon, making India the first country to achieve this remarkable feat. So this is because the south polar region of the moon has never been explored. Even though attempts have been made, they have failed, especially after Russia's Luna 25 failed in a similar mission. This achievement comes after a failed attempt in 2019 where the Chandrayaan-2's lander crashed on the lunar surface. So what is Chandrayaan-3? Chandrayaan-3 is a follow-on mission to Chandrayaan-2 to demonstrate end-to-end capability in safe landing and roving on the lunar surface. It consists of lander and rover configuration. The propulsion module carried the lander and rover configuration till 100-kilometer lunar orbit. So the propulsion module basically means the module which pushes forward the lander module. The propulsion module has spectropolarimetry of habitable planet Earth shape payload to study the spectral and polarimetric measurements of Earth from the lunar orbit. Here, spectropolarimetry means the splitting of the incoming light into its constituent colors. In this context, it means the technique which involves the polarization of light and then analyzing the polarization of each color individually. This is important because this could help scientists analyze the reflected light from exoplanets, and in this context the Earth, and determine whether they would qualify for habitability. This shape payload will accumulate signatures of exoplanets that may have features which qualify it for the habitability of humans. Scientists have always been on the quest to know more about the moon, whether it would be habitable or not. And this Chandrayaan-3 is such a huge milestone because one of its mission is also to one of its mission is also to study this to study and analyze the reflected light. So we may ask that why Chandrayaan-2 failed and why Chandrayaan-3 has become a success. So in short, the reasons for the failure of the Chandrayaan-2 is software glitch. This is because of the limitation of the software to detect errors and the small landing sites. This resulted in the crash of the lander when it touched down on the moon. So as a result, the scientists have come up with a better solution and a better way to soft land the Chandrayaan-3 on the moon. As you can see, this is the Chandrayaan-3 lander, and this is the Chandrayaan-3 propulsion module, and this is the Chandrayaan-3 rover, and this is the Chandrayaan-3 mission profile. This is the Chandrayaan, the lander and the rover together makes up for the lander module. The rover is fitted inside the lander, and together they are called the lander module. Propulsion module lasts for 3 to 6 months. Lander module is expected to operate only for 14 Earth days or 1 lunar day. Chandrayaan-3 consists of an indigenous lander module, propulsion module, and a rover with an objective of developing and demonstrating new technologies required for interplanetary missions. The lander has the capability to soft land at a specified lunar site and deploy the rover, which carries out in situ chemical analysis of the lunar surface during the course of its mobility. Here, in situ chemical analysis could be um, could be uh, could be like taking in data of the temperature, the chemical components found on the lunar surface. The lander and the rover have scientific payloads to carry out experiments on the lunar surface. The main function of PM is to carry the lunar module from launch vehicle injection till final lunar 100-kilometer circular polar orbit and separate the lunar module from propulsion module. Apart from this, the propulsion module also has one scientific payload as a value addition which operated post separation of lander module. The launcher identified for Chandrayaan-3 is LVM-3M4, which placed the integrated module in an elliptic parking orbit (EPO) of size approximately 170 into 36,500 kilometers. The mission objectives of Chandrayaan-3 are to demonstrate safe and soft landing on lunar surface, to demonstrate rover roving on the moon, and to conduct in situ scientific experiments. As we have seen, it successfully demonstrated safe and soft landing on lunar surface, which was able to successfully overcome the drawback of Chandrayaan-2. And here in situ scientific experiments means the chemical analysis of the lunar surface during the course of its mobility. And to achieve the mission objectives, several advanced technologies are present in landers such as altimeters, laser, and RF-based altimeters. Altimeters are instruments used for determining altitude attained. Velocimeters, laser Doppler velocimeter, and lander horizontal velocity camera. So velocimeter means instruments for measuring the velocity. Inertial measurement, laser gyro-based inertial referencing and accelerometer package. Propulsion system 800 Newton throttle-able liquid engines, 58 Newton attitude thrusters, and throttle-able engine control electronics, navigation, guidance and control, NGC part, descent, trajectory design and associate software elements, hazard detection and avoidance, lander hazard detection and avoidance camera and processing algorithm, landing leg mechanism. All these are important technologies that have enabled the Chandrayaan-3 to land on the moon successfully and as per the objectives of it. All these are very high technologies and advancement that the scientists have come up with in order to overcome the previous drawbacks. It has been around 3 to 4 months since Chandrayaan-3 was launched and successfully landed on the moon. Here are a few findings of Chandrayaan-3. About 2.06 tons of lunar epiregolith were ejected and displaced over an area of 108.4 meters square. Here epiregolith means lunar rocks and soil, or it could also be regolith, which means moon dust. And presence of sulfur. Presence of sulfur is one of the most important findings of Chandrayaan-3 because sulfur is not a common element on the moon, even though it is a very common element in the solar system. This presence could mean that there is water ice, which is a very essential element for humans to survive. This could mean that the moon is habitable for human beings. Found a host of chemicals such as aluminum, calcium, iron, chromium, titanium, manganese, silicon, and oxygen. First ever measurements of the near surface lunar plasma environment. So this initial assessment indicates that the plasma encompassing the lunar surface is relatively sparse. This evaluation specifically pertains to the early stages of the lunar daytime. Conclusion. Interest in the lunar South Pole as a standing site is mainly driven by the fact that scientists know the region holds water in the form of ice. Water is of course essential for life as we know it, but it also has other uses. For instance, it can act as a coolant for equipment and even provide rocket fuel. The latter could be especially useful for a staging mission to Mars launch from the moon someday. Landing near the lunar South Pole is not easy, and part of the reason for this is tied to what makes landing there so desirable in the first place. The shadowy nature of the lunar South Pole that helps preserve water ice means a soft landing there is tricky. Most lunar descent vehicles rely on cameras to guide their final approach to the lunar surface, ensuring to avoid obstacles and hazards such as boulders or craters. Landing is risky even on well-lit regions of the moon. Just one chance encounter between a boulder big enough to tip a spacecraft and a lander would end in disaster for the mission. Therefore, the risk increases substantially in the shadowy lunar South Pole. ISRO was integral in first detecting such lunar water to begin with when, in 2008, its Chandrayaan-1 spacecraft carried a NASA-provided science instrument called the Moon Mineralogical Mapper M3 to lunar orbit. This determined the existence of water ice inside craters at the moon's south pole. Thus, with such an incredibly valuable resource located around the lunar South Pole, it is a wonder the space agencies haven't already swarmed to get some space probes there well before ISRO's Chandrayaan-3 mission soft-landed. ISRO's 3 Chandrayaan missions have thrown more light on the presence of water ice, previously undiscovered minerals and elements, and temperature changes on the moon. All the Chandrayaan missions have produced unmatched quality of data for not only India but the entire world. This Chandrayaan-3 was such a huge milestone for not only India but for the entire world because with further findings of and discoveries of what's happening on the moon, of different elements on the moon, we are getting closer to the dream of sending human we are getting closer to the dream of habiting the moon someday in the near future. This was a very good experience for me, and I got to learn a lot about the Chandrayaan-3, and I hope you got to learn something about it too from this video. Thank you.